Aubrey, question for you.
Yes. Okay.
Not a question I've ever asked before. Have you ever used a slide rule?
A slide rule.
A slide rule, yeah.
Okay, that is an interesting one. Yes, I have in grade school. More of
Okay.
a, kind of experimentation, like historical artifact in a way.
Yeah.
They didn't make us use them. What about
Yeah.
you?
Yeah, I had one in secondary school, my GCSE maths class. We had one, like a big one mounted to the wall. I
Ooh.
often think it was the teacher's way of saying to us, if you mess around with your calculators, I'll confiscate it and you'll have to use this slide rule.
Oh, I bet you that was very effective because they're kind of scary looking a little bit,
Yeah.
right?
Oh, yeah, they are. They're very complicated. I mean, I guess they are more advanced than an abacus, and they were vital for people before we had easy access to computers. But they do obviously pale into comparison to what we can do on computers today.
Oh, for sure. I mean, it's pretty amazing to see how we were making calculations accessible even before computing was mainstream.
Yeah, yeah. And compute is what we're going to be focusing on in today's episode. So, I'm Michael Bird,
I'm Aubrey Lovell.
and welcome to Technology Now from HPE. Welcome to part 2 of the history of HPE in 10 Objects, a month-long mini-series to mark our 10th birthday as a company. Woohoo! Last week we looked back at the very birth of the company, but now we are moving forward in time and exploring the impact of compute on the world. Oh, and this is a video episode, so you can watch this episode wherever you watch video podcasts.
And if you are watching the video, you will know that we look extra smart today in our new HPE branded merch. All of these things are on our merch store. But anyways, let's get back to the theme of the day, which is compute. From the original computers, which filled a room with vacuum tubes, to the modern day computers, which fill a room with transistors, rare earth elements, and some of the most powerful computations ever performed, compute is one of the lifebloods of modern society.
Absolutely, Aubrey. But computing power isn't just available on supercomputers. Our smartphones can solve problems which engineers 100 years ago didn't even know existed.
And as a company which has been around for over 85 years, HP and now HPE were there every step of the way. And sidebar, HPE, like Michael said, is celebrating our 10th year anniversary, which is an exciting milestone. So, segue into that, Michael, what objects are we talking about this week?
Well, Aubrey, we're going to be exploring 3 objects: the ProLiant Gen 12, the HP35 calculator, and the HP65 calculator. Go and watch the video episode if you want to actually see these objects. So, Aubrey, to dive into the topic of compute, I had the opportunity to meet up with friend of the show, our very own Kirk Bresnicker, who is Chief Architect at HPE Labs, to find out more about the future and history of compute.
Very exciting. Let's take a listen.
So, Kirk, we have 3 fantastic items in front of us, but I want to start with the larger one, the larger item. What are we looking at here?
What we are looking at here is generation 12 of a ProLiant DL380 server. This is the workhorse, the foundation of our industry standard computing line.
And why is this object so important to HPE?
Well, it's fun for me to think about this system because I originally encountered the ProLiant not as the product of HPE engineering, but when I was at HP and the ProLiant was from our competitors over at Compaq, I would meet these in our comparative teardown laboratory. We were always going head to head up against the ProLiant, and so it was a different idea. It was a different method. We had taken basic technology, semiconductor processing, computer architecture, first with the HP classic computer architecture, then our own PA RISC computer architecture. And in the case of this, the Gen 12, and this is near and dear to my heart because it's some research that we helped at HPE Labs to help the team think about. This is the first industry standard server that is post-quantum cryptography safe on the firmware update. As a matter of fact, I was just at the Semiconductor Industry Association conference in Phoenix 2 days ago. Someone asked one of our partners/competitors, hey, what about post-quantum cryptography and your offerings? And the gentleman made some polite noises. And as soon as I got onto the stage, he said, oh, by the way, gentleman who asked that question, ProLiant Gen 12. We're shipping it. Yeah, we're ready right now for the question that you asked. And it was the right question and the right time to ask that question. And I think that's really the hallmark of this team, always to be adding on top.
It's our 10-year anniversary. How has ProLiant changed over the last 10 years?
I think the individual feature, that next thing that's, oh, wow, that thing that's, you put that at the top of the new data sheet. Hey, Gen 12, you got post-quantum cryptography for firmware update. But if we go to 11, 10, all the way back to 1, you're always going to find a series of introductions that were industry first.
All right. So we've talked about the Gen 12. I want to sort of rewind back a bit, and I want to sort of talk about how we got here. So the HP 35 calculator, I mean, can you pick it up, describe it to us?
Yeah. So this is the first personal computer. This was a computational device that had some very direct feedback from our founders. Bill and Dave thought about what is the engineering tool that they would like to use, because there were calculators before this. They might have been the size of washing machines. And so Bill and Dave said, we need something that can do the calculations that engineers and scientists need to do. It's not just multiplication, addition. Hey, where's my sine? Where's my logarithms? I need to do all of those things to do engineering. And I need you to be able to have it fit inside my shirt pocket. It needed to have a battery that lasted all day. And it needs to do all their calculations. And this is really a combination of technologies that started in Hewlett-Packard Labs. Things like the first commercialized, and unfortunately we don't have power here, but if we did, we see those beautiful red 7-segment LED displays. First commercialized LED display was from HP. You would make sure that all of your nerd friends saw this in your pocket, because this meant that you didn't have a slide rule on your belt anymore. You had really had invested in yourself and your ability to excel as an engineer, because you had come into possession of an HP 35C.
And I mean, this must have been so revolutionary to the people who it was aimed at, engineers, etc. And before the personal calculator, you were using a slide rule.
You could use a slide rule. Maybe you had one of those mechanical 10-function machines, because if you're using a slide rule, you're already using logarithms. Maybe you have your table of logs and sines and cosines, and that means you can do multiplication by adding, but you still need to add 10-digit numbers. Now we can do that on a nice 10-key adding machine, and have that chugging away. So we had those simple mechanical additions. There's no hourglass. There's no weight. There's no going into a batch queue. You're staying in the zone, and you are exploring, and you're thinking, and this device is keeping up with you wherever you are.
I mean, saves masses of time, it sounds like.
It's not only time, it makes sure that you're always thinking, because it changes the way you behave as an engineer or scientist, because it's all real time and it's yours.
So why is this object in particular so important to HP's history, do you think?
I think about how many engineers have done just what I'm doing, right? Who are thinking about something and punching it out on their HP calculator, and it started that community, right? It was that way that they made themselves individually more productive. And when we get to the next in the series, which only came out like 18 months later, so it's an incredible leap forward, we'll see how that went from individual, making each individually being more productive, to being an incredibly productive community, which came out with the next generation.
Okay, that leads us really nicely on to the next object.
So this is the HP 65. And first thing you know, it's a little heavier.
Let me feel the weight.
Yeah.
Oh yeah, okay. Yeah, a little bit heavier.
Yeah. So it has an improved battery, improved processor. They changed the style a little bit more. It's much more ergodynamic, and it has got the sloping sides on both sides, and that made it easier just to feel and to hit. They raised them up a little bit, and just made it more physically useful. But the other thing about this one, and the most important thing, is this switch: program and run.
Okay.
because this is a programmable calculator, right?
Okay.
And that was the incredible leap forward. This was great because you think of all those things that you did on your slide rule, all the logs, all the sines, the cosines, the powers, all of that. You still had to have something else to do the calculation unless you were going to add up all those numbers yourself. But what this allowed you to do was to take a calculation of arbitrary complexity and not just key it in once. You programmed it in once, and then you could hit the run button and it would repeat it. Now, that's already powerful, but what this added was logical decision making. You could compare things. You could say, hey, is the top of the stack, the X register, is it bigger or smaller or equal to the Y register? If so, if then, right? That's how we get to real computer programming. This is the first computer I ever programmed. The other thing about this one is the little slot on the side is where you could stick a little magnetic strip in. We got some strips. You could stick a strip in, and you could save your program, and then you could copy the program, and then you could share the program.
It feels like the start of the democratization of personal computing.
That's absolutely. So what used to be a whole room, now it fits in your shirt pocket. Not only is it doing a fixed function, now it's programmable, and you have a community all about it. So yeah, and again, I remember when my dad got his, and he and I stayed up that night doing exactly that, keying in the programs, trying them out, and then just understanding what this could do.
What was the knock-on impact of this device to how we got to this?
So there's a couple different directions that went. It created that concept. You mean an individual person can own a computer that they put their name on and then they can customize to do their job better? Well, that led to the idea that, we'll continue to grow these up. And so then this went on to home personal computing and then office personal computing. Back in the day, it was HP terminals. A simple device. It had a keyboard. It had a display. It was just there for you to talk to the mini computer. And it was so however many you used to pay by the number of terminals that you could attach to a mini computer. That was part of how you licensed the capabilities. But suddenly I got this new desktop personal computer on my office desk, and suddenly it can do some more of the job. I don't have to do everything on the mini computer or everything on the mainframe, and that's became what we called the client. And so what a client needs is a server. So that's really what really shaped what this product, the ProLiant, became. It's like, what's at the other end of now that network cable? So that's one line. Now the other line that comes back in here is people looked at that microprocessor in that desktop personal computer, and they said, I wonder how far we could push this technology. And that really was what became the industry standard server technology that went in here. So it really was balancing those two things out. So there's a lot that was derived from creating the world's first personal computer.
Wow. So why do you think this object is so important to HP's story in particular?
Because this is also, creating that community. This was something that was bigger than us, that we started, and then, we were members too, right? We were contributing as much because we were engineers, we were scientists, we were helping out. This
is a ProLiant server. You just touched on it. HP merged with Compaq back in 2002, I think. How has ProLiant evolved since then?
So in several ways, and it's funny because I got to go to Houston. I think it was about a month after the merger, and back at HP before we joined forces, I was trying to get anyone in HP interested in something that was starting to call blade servers. I go to Houston, I meet my kindred spirits, right? And I meet the teams that was not only designing the ProLiant, but they were designing that first generation. Actually, they're on their second generation, moving on to the third generation of exactly what I wanted to do with blade servers. Now, the ProLiant itself, the DL3, it continued on, and every generation they add, and they add new features, new understanding, because not only does the enterprise application set change, but the enterprise IT teams, they grow and mature and change as well. So that ability to every generation is the culmination of that technology understanding.
So we've talked quite a lot about ProLiant. Where does GreenLake fit into all of this?
So GreenLake, one of the things, when we were doing our own proprietary systems, our Unix systems, we think, boy, industry standards coming strong. Some customers, they look at these products and they're like, I still need to use these kinds of products. I want the agility of cloud, but it might be my regulator, it might be my own concerns of risk, of security. How do you offer them that cloud agility and experience and still be able to ground it in this class of product? And that is what GreenLake offers it.
And I mean, you sort of touched on this, but data sovereignty is becoming, quite a big talking point at the moment, isn't it?
When we were together in January on that nice snowy hill in Switzerland at the World Economic Forum annual meeting, we were also at the AI House. And every conversation in the AI House, no matter how it started, it ended up being sovereignty and sustainability.
So, Kirk, I mean, what we've touched on here is personal computers. And I mean, I don't know about you, but I sort of feel like the equivalent of this is the smartphone. Like today's equivalent.
Well, today it's one app on the smartphone.
But the power that we can hold on our hands today, why are we still using server infrastructure?
It's interesting. At Discover a couple of years ago, we had just introduced the exascale. Yeah. And so there was the Frontier cabinet. It was right there. And I was given a very nice piece of real estate to talk about our quantum computing research at HPE Labs. I was next to the Frontier. On the other side was Cray 1, one of the first Cray supercomputers. And just sitting there, and we had a slight velvet rope around such a VIP. When you're in Vegas, you have the velvet rope. And there was a steady stream of people who came by, and they had to take their selfie with the Cray. And because I was the closest team member next to the Cray, they would say, "Hey, you Labs guy, I see that Frontier system over there. How much faster is that system than the Cray?" Well, I say, each one of those individual blades is about 40,000 times faster. But just so you know, that phone you just used to take your selfie is 10 times faster than that Cray system. That's because what we need to compute continues to rise. And if we really want to make AI outcomes equity available to hopefully eventually 8 billion people, not just the 2 billion today who have access, then we need to do more compute, and we need to do that in a sustainable way, which means we need to do a lot more with a lot less.
Do you think we're going to see, particularly with the rise of AI, the increase in use of AI, do you think we'll see more or less edge computing?
We're doing a lot of this today, and we each have an edge computer on our wrists, right? We're going to continue to see these devices proliferate. And what is going to drive it is that when we have an AI model, we're taking the knowledge and experience of an engineer, a scientist, a decision maker, we're turning it into a model, and that allows us to project that intelligent human faculty into some very inhospitable environments. Put it at the bottom of an ocean trench, put it up in low Earth orbit, put it out in the hot zone of a viral outbreak. That ability to extend human intelligence into novel areas and to operate autonomously on our behalf. That's the power of edge computing.
Okay, so Kirk, hopefully we'll do this in 10 years' time, and we'll maybe have the latest.
Yes, the latest.
You know what my question's going to be, don't you? It's the question every technologist says. What do you think we're going to be sat in front of in 10 years' time?
We have not a 10-year roadmap, we actually do a 15-year roadmap, because that's just far out enough so that you're not worried about being inhibited because you'll have to make a big investment, but it's not so far out that you're just wildly speculating. One of the things that's consistent is what we call design envelopes. And this is one of those really important design envelopes. It fits in a rack. It's about this deep. And what can you pack with the kind of power we have coming in, the kind of cooling, including liquid cooling, and this kind of has been around for a while, and we will expect this design envelope to stay future and keep on going.
Kirk, this has been an absolutely fascinating conversation. I could just keep talking to you for hours, but we do have to end at some point. Thank you so much for joining us.
Sure thing.
On Technology Now. Really appreciate your time.
Absolutely.
That was really fascinating and so interesting to kind of walk through time and see the ripple effects of these decision points. And okay, when this technology was made, think of how different the world would be if those things did not happen, right?
Oh, totally. I loved hearing about both the HP 35 and the HP 65 calculator. I had the opportunity to pick them up and touch them and play with them, and just to sort of feel how far we've come on from then, but also how it sort of felt so familiar to me. It's just, it's just a calculator, but actually talking to Kirk about how revolutionary those devices were, particularly the 35, to the way that people, thought about and, did maths, basically.
When we look back on our history, it really does give us an appreciation for how HPE is kind of a founding, such a presence in the technology world. Like, I loved what Kirk was saying about the community, like basically forming this, digital community that the roots started there and has grown into what we have today. I think that's really important in the knowledge share of how we've advanced all of these little things for our everyday life to make it so much faster. Like, can you imagine today doing all of our calculations using a slide rule, and then it took you all day just to get that done? But, with the technology today, it takes seconds, right? It's incredible.
He talks about staying in the zone.
Yeah.
So he basically said the calculator allowed you to just sort of be like, okay, I've got this thing, and, calculate through it, blah, 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 and not have to wait for an answer. And I think the parallels of the way that actually we work today in our modern world, you're so much more efficient when you can rely on your computer, you rely on your infrastructure to just work. And actually, that's what these devices did.
Yeah. Exactly. It frees you up to focus on what's important, right? With innovation and, thinking in different ways, whereas before you couldn't, like you were just so focused on the manual process of doing certain, basic calculations, right? So I'm excited to see where we go forward, right? And I think my biggest question too, Michael, you have to wonder, is there ever a stopping point to that?
One of the things Kirk said was, what we compute always continues to rise. The going from actually the compute we did on a calculator to the compute we do today, actually the compute we're going to be doing in 10 or 15 years' time is going to increase massively. The demands we're going to put on it. Yeah, I think we're going to continue innovating. Now,
for sure.
Aubrey, we talked about slide rules at the top of the show. Do you have any idea how to use a slide rule?
I remember learning about it, but I don't know if I would want to. I might leave that to Kirk and other very smart people to deal with. I think I'm very comfortable with a calculator. I'm too spoiled.
Do you know what, me too? But I sort of felt like I really wanted to sort of understand this thing, because I looked at it and I couldn't even sort of fathom how it worked. So when I was chatting to Kirk, I asked him to explain it for us.
The principle of using a slide rule is that if we wanted to add two numbers, let's say you had a 1-inch ruler and a 2-inch ruler. Well, I could use those. I could put them next to each other, and now I'm measuring 3 inches by adding them, right? Or I could put the 1-inch ruler next to the 2-inch ruler. Look at the difference. I can do a subtraction. So I can add and subtract by taking rulers and sliding them next to each other. I really have to put on my glasses in order to see these tiny numbers. But there's two pieces to the slide rule, actually three pieces. First, there is the fixed portion, the fixed scales, and then there's the sliding scales, and then we have this vernier with a line, and that helps us to get exactly where we want to and line things up from top to bottom. Because what I'm going to do is I'm going to adjust one of the scales to be a certain location with respect to the other. So let's say I wanted to multiply 2 times 3, and we have two scales here. So I'll put one end on 2. So now I've lined up the 1 and the 2. Now that if I go over here and look over the 2 or look down below, there's 4.
Wow.
So 2 times 2 is 4. 2 times 3 is 6. And if I want to get precise, and I'd line them up exactly using this. I'd then slide this over, and because I might want to multiply 2.5.
Yeah.
So then I'm going to go in here and I'm going to move this halfway in between some of those divisions, and that's how you would get precision.
All right, well, that brings us to the end of Technology Now for this week. Make sure to come back next week for our next installment of the history of HPE in 10 objects, where we will be talking about networking. And thank you so much again to our guest, Kirk Bresnicker. Awesome to have you. And of course, to our listeners, thank you so much for joining us.
Yeah, and if you've enjoyed this episode, please do let us know. Rate and review us wherever you listen to episodes. And if you want to get in contact with us, send us an email to technologynow@hpe.com. Subject line, slide rule. And don't forget to subscribe so you can listen first every week. Technology Now is hosted by Aubrey Lovell and myself, Michael Bird, and this episode was produced by Harry Lampert, Izzy Clark, and Spencer Trenwith, with production support from Alicia Kempson-Taylor, Becky Bird, Elissa Mitri, Rahil Ali Mohammed, and Renee Edwards. Our video editor was Mikey Nissenbaum, and as always, our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green, and our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett-Packard Enterprise, and we will see you at the same time, the same place next week. Cheers.
Cheers.